Here we go. My name is Rob Humfeld. I work for Jet Engineering. Jet is a Alliance member company, basically a system integrator. We work for lots of different other companies. We're based in Cedar Rapids, Iowa. I personally am in Columbia, Missouri. I work from home most of the time, and I serve more customers in that region for the company. So, did I want you to come here? And these are the things I want you to walk away with, really, is that subscription-based messaging really brings significant value to your project. Then my framework, which is called JASMA, I may use the name JAMA accidentally, but it's called JASMA. I just want to share with you some of the requirements and design decisions I made. I kind of mixed those two together. I'm not being very much of a theory purist in that sense. That opens up opportunities and might be worth trying, and most importantly, that your favorite NIWeek talk had Katy Perry in it. Oh, sorry about that. So what's the problem that we all face? Well, reality is the problem, right? So you have unpredictable nature of stakeholders. You have inconvenient truths that appear after the design is quote-unquote finished. The inexact nature of requirements that do exist at the beginning. And the unforeseen needs of the initially uninvolved. How many people have ever had a project where you're halfway through and some new person shows up and drastically changes the direction? Yeah, that happens. So fundamentally, this is the problem, and I came up with this. It's a restatement of something I'm sure everyone already understands, but it's the universal law of software thermodynamics. The life expectancy of a system approaches zero as the interdependency of its components approaches infinity. Right, so what am I talking about? The real villain coupling. We talked about spaghetti code, but this is spaghetti in the even more abstract, which is all of these interdependencies that can and potentially will exist in any given software system. So what we're really looking for here is low coupling so that we can have independent modules and maximize reuse. So what is the solution? Well, if I am coming to this project, then what is it I want? I want to easily integrate portions of software development that are developed independently. I want to easily support my software for at least a decade of changes. I want to delight my customers. This is the most important one for me. Delight my customers by quickly adding new features. I want to ensure that my minions, who might be non-experts, are all on the same page. And I want to minimize the learning curve as much as I can. So that way, folks who come into the company, I'd like to be able to get them billable as quickly as possible, but not only just billable, but actually providing real value. In short, I want a sweet, delicious, melty feast of software perfection that, if you're familiar with Norm Kirchner, you would know is called s'mores. I'm going to borrow this concept. It was originated by Tim Jones, but it's been promoted by Norm. You may have gone to a talk. It was complete happenstance already at NIWeek about s'mores. S'mores stands for scalable, modular, reusable, extensible, and simple. So basically, it's an aspirational goal for software that you write. Oh, sorry about that. So we're going to talk briefly about a very simple DAC application. So let's just say we want to acquire some data, want to present some data. Obviously, we're talking at a pretty simple level. So modularity would say we need to separate the functionality. So what do? I said, well, so let's just say there's this generic data acquisition module over here. It's supposed to read DACMX data periodically. You have an operator interface module over here. And it's supposed to provide a start button and a data dashboard display. So just basic stuff, right? In JASMA, we call them J modules. So if you hear me switch between modules and J modules, it's just the language that we adopt. That also happens to be the name of the class that we use. So what's a J module? It is an asynchronous actor. But when I say actor, that's independent of the actor framework. Actor is a generic term. It's not owned by the actor framework. It is defined within a class. It is a queued message handler, but that's independent of DQMH, because that's not necessarily specific to DQMH. It does have local state data. It uses one while loop with the QSM toolkit for state navigation, and it's built using good conventions as defined by me. So you may disagree with that. I don't really want to get into the style discussion, and when you look at my code, you can cringe. I'm okay with that. If you have something to share with me that you've learned that you think would help me, please feel free. At the end, I'll show some examples. So, how does data from one module get presented in another module? Well, messages are the answer, right? So we're going to have these two modules. They're going to talk to each other with some generic conceptual messages. So my first requirement, messages must be able to carry unique data. A good requirement.
Why unique?
What's that?
Why unique?
Good question. So the message types need to be unique. The data need not necessarily be unique. So that's good. And obviously there might be some messages that have no data at all. By unique, I was trying to say that they can be unique to that particular message type. Okay. So if I want to be scalable and extensible, a good choice for all of you folks who are not super comfortable with object-oriented is to have a message class. And what you can do then is you can inherit your specific messages, can inherit from the generic message class. And so the API you write for sharing messages around will all be at that parent level. And so your API won't really care that there's all these differences. At any point, you can add more messages. So that's the general concept of messages and object-oriented. We can talk about implementations of that in more detail if you're interested. I know a lot of folks here are familiar with that. But I don't want you to feel intimidated if you're not super comfortable with object-oriented. Most of this is already done for you, or it's fairly simple. I saw the other day that somebody said that that classes are LabVIEW libraries that are just extended. I like to think of it the other way around. If you're comfortable with clusters, you should be able to become comfortable with object-oriented fairly easily. I think of the class as simply being a cluster on steroids.
Why do you think message should have the receiver should know how to handle the message? The sender has no business of knowing how the message will be handled by the receiver, right?
Yeah, that's partly what I'm going to get to. What I'm saying is that each message type will have a particular data content to it, and how the receiver handles that content is up to the receiver. Absolutely. The read is just to get the data out of the message and into the module that's receiving it. So that's the receiving module. So this is a difference between actor framework. So in the actor, you have a method, the do method, which acts on the data within the message. Is that correct? Right. It's different. Right. So in the actor framework does that. I don't. And that's one reason why it's easy for me to talk about decoupling, whereas it's not as easy for actor framework. So some other design decisions here. I'm just going to call the parent class JMessage. And it can deliver a unique message payload we talked about, otherwise data. And this is the key point we were just discussing. Execution and handling is part of the module. It's not part of the message. The message goal is to deliver data or to deliver a command to the receiver. It's up to the receiver to figure out what to do with it. So let's just give an example. We've got a start test message going from the operator interface to the data acquisition module. We have a data packet that will come back, let's just say periodically. Or in the future, if we want, we can split that data packet. Maybe it used to be combined digital analog data. Maybe we want to have digital data separate from analog data. Might be we want to have two separate modules, a digital module and analog data. It really doesn't matter. That's the nice thing about the extensibility is you can just kind of switch those around without worrying about the receiver as much. Okay, so how are they transported between modules? Well, there's really clearly only one function that you would want to use. It's the queue user event notifier functional global data value reference channel wire. I could keep going function for passing messages, right? Well, I'm going to just say that my only real requirement here when starting out was that polling must be avoided. So I'm not interested in global variables. I'm not interested in functional global variables. Really, I'm not interested in reading serial data since you have to poll that, but sometimes you don't have a choice. So I'm going to avoid polling if I can. And so I'm going to just start out by saying, we'll just throw out everything except queues and event structures. And in my opinion, queues are far superior to event structures in terms of messaging applications. The reason I say this is the top two, sending or receiving messages and having an idle timeout as being features that you need. They're important and they're handled by the event structure. But some things that I like to have in my messaging structure would be message prioritization. Or querying the status. Like with the event structure, there could be a million messages that are waiting to be handled and you wouldn't know it. And then having targeted messaging. You can do that with event structures, but it's, I think, a lot clunkier than with queues. So I like queues, so I use queues. So that's my design decision here. Now, I will point out that the modules that are UI modules, they do have to have an event structure in them, right? Yeah, in order to read the front panel controls, right? So the way I did that is I have a daemon, and that daemon receives messages from my messaging framework and then passes them to the event structure. You could do it the other way around. I think TQMH does it the other way around effectively. Yeah?
Just had a quick question. You said events don't have prioritization. Are you referring to something other than the priority input on generic user events? Because you can prioritize user events.
Okay. Well, this I am not aware of.
Okay.
I haven't used user events really since 2006, I think.
It was added a few releases ago.
Oh, okay.
So I just wanted to make sure you weren't referring to something I wasn't aware of.
Great.
Yeah, that's.
Yeah, and we can, if there were someone in the room that had something to do with writing a LabVIEW, we could talk about how all the features I'd like to see in the event structure and how I would use the event structure. But I've found it convenient for the last decade to use queues.
If you haven't used it since 2006, then yes, there are many things we can talk about.
Oh, sorry. So you might be thinking, especially if you're new to this conversation, that if you take that and you extrapolate it to, say, 5 different modules, that could start to look a lot like spaghetti, right? You would imagine. So the challenge there is, how do you decouple it? How do you make a brick wall in between these two? You have to have some kind of messaging solution, and the solution that I use is a subscription solution. So I thought, well, what other models exist out there for subscriptions? And I thought, well, Twitter is a model. So let's say that you're a starlet that is singing and would like to make money off your songs. How do you market? Do you have the address of each of your fans and send them all emails? No. That's what my very first framework looked like. You don't do that. You use Twitter. How does that work? Well, you have 106,937,266 people, yes, I did look it up, that subscribe to you using Twitter. And you send out messages, and it goes to all of them. But unfortunately, she doesn't know any of those people. Sorry. So from the subscriber perspective, how does this work? Well, basically what you say is, I'm in love with Katy Perry. I want to know everything Katy Perry says. So Katy Perry might say a lot of different things about a lot of different topics, and you get them all. Right? That's not really what I'm going for. Right? Here's what we actually want. You want to say, I'm in love with the NFL. I'm not in love with Katy Perry, I'm in love with the NFL. I mean, I'm a big NFL fan. Right? Katy Perry, she might talk about the NFL occasionally. There might be other people who talk about the NFL occasionally. Raise your hand if you recognize the picture. Just curious. Okay. So instead of getting everything from Katy Perry, you get everything that everyone says about the NFL. Okay? And you can be as specific as you want. It might be that you are looking to get a job in the NFL as a tight end. So you might want all the news about tight ends in the NFL. Right? So this is really more the model that we're looking for. We want to subscribe to a message, not to a producer, is the idea. So modules have to be ignorant, just like Katy Perry, of one another. Katy Perry doesn't need to know who I am for me to subscribe to a message from Katy Perry. How does this work? This works using a subscription model. So we have these Jasma subscriptions that are maintained independently. So for each message, I can subscribe for any module to send or any module to receive them. So here, the operator interface module, it sends out the message. It doesn't know who is receiving it. When the data acquisition module receives a message, it doesn't know who sent it, necessarily. There is data that's in the message if you want to know, but you don't care in order to receive it. Let's say you have a data packet message then that goes out of the data acquisition module and goes into the operator interface module. All right, so that decoupling, what it does is it allows you to make changes to each of those modules without affecting anything else. So operator interface can add a trend chart to its display. Data acquisition module can decide, hey, you know what? I want to oversample DOCMX channels and average data periodically instead. And so your messages are protecting the rest of the application from those changes. You can even swap in an entirely different module. Or you can have another module that runs in parallel that receives the same messages. Maybe that doesn't send out the same messages. It depends. So, the implications here. Oh.
Do you implement a separate actor to manage subscriptions, or the user interface is a public?
Right, so that's a good question. So in my original framework back 10 years, 15 years ago, I guess it was, I had what you could call an actor that was like a hub, right? I don't do that anymore because it became a bottleneck. I did not want to have a shared resource that was having to handle those. So every module can handle sending messages to whoever had subscribed to that message.
Where's the database of who subscribed?
Yeah, who maintains the subscriptions?
Right, so what I do, we'll get into it in the code, but what I do is I create a DVR that has in it the subscription information for a message. And that DVR is stored in a single element queue. So I can reference a single element queue that you can reference by name. So you reference it by name, and then you take out the DVR, you get the information, you modify it if you're subscribing, or you just preview it if you're not subscribing. And that way you... No, there's a queue for each message. So there's two kinds of queues here we're talking about. There's the queue where you send and receive messages. What I'm talking about is how I store the subscription information, which is separate. Yeah. Every actor can get that information, can get to it. I can show you the code. So the implications here is that any given message could have any number of subscribers and/or producers. That modules can join and exit the sort of communication fun at any time, and that no module needs to be dependent upon any other module. Now, obviously, every module is dependent upon the messages that it sends and receives, or that those are dependencies of that module. But it means that the modules are completely ignorant of one another, which was ultimately my goal. Right? So you can independently modify, write modules. Debugging gets a lot easier. And loading a module doesn't force another module into memory. So the key concept, again, no module knows or cares what other modules are running, what modules are receiving, what modules are sending. They just don't care. No, it still won't care. I mean, the information, it doesn't care who it comes from, really. So extensibility here is a system whose internal structure and data flow are minimally affected by new functionality. And it can also be seen as a measure of the level of effort required to implement any given extension. So let's talk about that a little bit. Let's just say that we wanted to add something to our little simple application. So we add an alarm manager. Well, to have an alarm manager, you have to receive data. So we just subscribe to receive the data packet message. And then once you evaluate it, you get out an alarm condition. So then you subscribe to send that message. Who's going to get it? Well, probably makes sense to have the operator interface module get it in this case. So we just subscribe to receive that message. Let's say we want to be able to configure the alarm conditions. We'd have the alarm manager module subscribe to receive the alarm configuration message, be a new message for us. And we might have the operator interface module be the one that configures it. Or maybe we say, you know what, I'd rather have a pop-up do that. So I'll go ahead and create a separate module, the alarm configuration module, that can still send that alarm configuration message out. And maybe we want to display something about the alarm configuration on the operator interface module. So we just subscribe to receive that and do whatever we want with that information. Okay. Everybody follow that pretty well?
Yeah, sure. The need you subscribe to the publish.
Okay, so I'm almost there. So the key requirements decisions is modules have to subscribe for messages, but they don't own those messages. There's a final application. So what about reuse? Well, you can imagine taking any number of pieces of this application and packaging them however you wish. You can take all your messages and stick them in a library. In Jasmine, we actually have a bunch of common messages that we just kind of spun off and we use in all of our applications.
Do you combine them into topics, and the topics have multiple different messages, or different different messages in separate topics?
That's actually a concept that I haven't explored much. I have heard of that concept, but I don't deal with topics.
NFL-related information can be, categorized into what
Right.
you may not be interested in all NFL information.
Right.
Basically.
Yeah, so I just do it on a per message basis. I don't deal with topics.
Content-based subscription or the topic-based subscription?
Content-based.
Okay.
So the question is, we've got scalable, modular, reusable, extensible. I've tried to address those quickly. So is it simple? So here's kind of some common tasks. I have folks that I teach this to fairly regularly. So I want to make sure their life is as easy as possible. The kind of basic things you would want to do here are subscribe, send, receive, create messages and modules in debug the system. And so I'm trying to maximize the amount of work not done by the developer. As Dimitri likes to, it's on your card, right?
Yeah.
I told you, he's very much effective. So you help the developer produce easily readable code, notify the developer of common coding errors, and support common use cases are my goals. Am I all the way there yet? Not necessarily. But let's go look at some code. And this resolution is a little bit different than what I'm used to. But just as an example, I'll show you over here is kind of your basic application with two modules in it. You can see that you've got an engine for analog inputs and a UI for test execution. We have two messages. There's data AI and test start. If you look at any of these, if you're not that familiar with object-oriented, each of these can have unique data in them. So the AI data has just an array of numbers for this example.
How do you launch
And the test start is empty. The question was? You can choose. In this example, for simplicity, I am just launching them statically in parallel. But you can dynamically launch them. You can clone them. You can do whatever you want, pretty much. Also, there's one piece down here, which is a module that is commonly used with Jasmine applications. So if I run it, then I hit the start button, and oh look, I have a problem. So this is that module I was pointing to. It actually is catching an error that I have in my code. So it's telling me that that the subscription list is empty for the message I tried to send. So this is the message right here. But
Let's pop up for the actor, or the central actor.
no, this is from this actor down here, this exception handler right here. And so this will give you a history if you have a bunch of them, and it'll log the file. But I put that in there purposely so that we could talk about the exceptions. The exceptions logged in this file here for this list. So let's talk about subscription then. So the analog inputs here, this is the analog input module. The problem was that I had not subscribed. Now I'm doing this statically as a type def cluster. You can obviously instead pass in an array, so you have the dependency injection that we like to have. But I'm doing this for simplicity's sake. So if you just take your test start message and you drop it into your received cluster, now I'm subscribed. So hopefully this will work. I hit start. You can. You can. So you can see here that the analog module received the start, so now it's actually generating data. But you can see that I have another exception problem, which is that the subscription list was not found the other way around. So it says the module did not register to send the message. Okay. So the reason all of my modules have to register to send a message and have to register to receive a message, and the reason it has to do with that trying to keep the dependencies down. And so I have a separate list for that. If you look in this module again, I have a TX list. So this is all the messages that it's allowed to transmit. So I would take the AI data message and I'd drop it in there. So that's how you subscribe to send. It's exactly like subscribing to receive. And like you were just asking, I don't dynamically.
Can you?
Yeah, you can, absolutely.
While already running,
Yep.
I'm not going to send the subscription, subscribe.
Yep. No, it's not a subscribe message. It's actually a function that you do on your wire. So if you look at let's see what I do.
So it's a method call on what class?
It's a method call on the JModule class. So if you look at this this black and blue wire here, that's your JModule wire. It's extended by, or this module inherits from the JModule wire. So if you look at, say, when we receive a when we receive a message that doesn't have any data in it, let's look at user interface. So a good example is right here. So this is an example of receiving a message. So every message has its own state in here. That's, again, the static. The active framework would handle that by using a do method. This is basically, instead of doing a do method, it's just a state in the state machine. So it goes here to this data AI J message. And this right here, its purpose is simply to get the specific data out of the J module. So when we were, the event check is right here. So you can see that it's pretty straightforward in terms of that all you're doing is there's one state that receives a J message right here. If you want, you could override that and make it more of an active framework kind of actor, where you would have your do function would effectively be right there. But I like to actually do it with a little bit more explicitly for my minions. So you've got your QSM state that comes out here, which is just the name of the message. So then it would go here, you get the data out, and then act on it. Typically, I don't put the chart in this here, but for the demo purposes, I do. You were asking about subscription, how that works, and sending. So let me find an example. Let's say we want to, when we send the stop message, there is in the start message the send is right here. Now you guys won't need to know any of this stuff if you're using it, but effectively what you have is a subscription class, and that subscription class, based on what type of subscription it is, will send a message to a particular place. And so this is ultimately where the message happens, where the send happens. So we're just taking the J message in, we're putting a timestamp on it, that's the sent time. Before this point actually does put the name of the module that sent it for debugging purposes, and then sends it out using a queue. How that gets that information is primarily, I think, what you were asking. Is effectively, right, if you look here, this is your subscription. So every message has a list of subscriptions. So this is the basically the information about the modules who are interested in receiving it. That information is stored in a single element queue. That's being previewed right there. And that queue is being pulled out of a lookup table right there. Yeah, question?
When you're sending a message out from the sender to all the subscribers,
Yep.
the sender's thread is responsible for actually sending the message. So
Yes.
And then it's going through and saying for each subscriber in order.
Yes.
It's not a broadcast, it's more about
Right.
dealing out cards.
Yep, dealing out cards, that's exactly right. So you can subscribe to as many messages as you want as a receiver. But the question about subscription, I think you're going to talk about that a little bit, about the address messaging. Yeah.
Yeah, who maintains the subscriptions?
Say again?
Actor,
message
publishers,
separate.
or they're centralized?
So the way it works is you have your lookup table here. This is a send, right? So I said that you subscribe to send. And the reason you subscribe to send is that you are basically building this variant lookup table right here.
The table is stored where? So I'm an actor, right?
Yeah.
I want to subscribe to some message to be notified, right? So where is that table stored? Not within the subscriber, right? Not within the publisher, somewhere external. I understand.
Right. So let's just start from the beginning here. So you have a variant lookup table.
What is this code? Is this code for an actor or some external?
This is a VI that is called by any module that sends a message.
Okay, so it's a common.
So it's part of JModule.
Right?
Say again?
It's a single, and it has only one. It should have only one copy of that table, right?
No, there's not. No, there. So this is a re-entrant VI that's called by a module. So every time you launch a module, then there is a copy of this VI in it. The subscriptions are ultimately stored in this wire right here, which is stored in the lookup table. So when you subscribe to send a message, then what you're doing is you're adding a message name to the lookup table and its associated DVR. So that DVR contains a list of the subscriptions for that message.
Is it a singleton within the application table?
Where does it live in memory? That's the people we're trying to get at.
Right.
Is it application available?
Right, I understand.
It couldn't be, right, because each module has to maintain its own list of what it sends and receives. So each
Well,
module-
Right, exactly. And this
Publisher
is,
should know its receivers to whom to send those.
it doesn't necessarily, no, because it's tied to the message. So what it's doing is it's looking it up at the moment. So like you asked about, can you dynamically subscribe to receive a message? And the answer is yes. But you don't dynamically subscribe to receive a message by sending out a broadcast that says, I am now interested in this message.
No, you should send such a message to the publisher.
No, you don't do that either. What you do is you add your information, your module's information to the subscription list for that message. So there's
Which is global for the entire application.
the subscription list for each message is global to the application. That's the right way to say it, yes.
Using the main queue, right?
So and there are
Yeah.
multiple lists for each message.
There's one list for each message.
Multiple lists for different messages. Each list contains all the subscribers.
All the subscribers for that particular message. Correct.
Okay, and
Right.
each of these lists is global to application.
Correct.
So it's topic-based.
No, my understanding of topic-based is that you might have multiple messages that all share one topic.
Oh, that could be the case.
Right.
So that's not the way it's done. But what that does is it allows you to decouple the senders and receivers from one another. And also what it does is it allows you to take out any shared resource. So that was, like I said, my previous framework had what I call an event handler hub type thing. So it would receive the incoming messages and then shuffle them out.
So what's the
Right.
dispatcher mechanism? You should have some dispatcher that looks, watches for every message generated and decide to which subscriber to send it, right, to forward.
No, I don't think so.
No, there's no dispatcher. It's just this right here. It's just this array of subscriptions. So each subscription contains the information of one receiver. Yeah.
Could you quickly explain how named queues work? I understand there's some type of lookup table within LabVIEW.
Darren? I don't. I mean, under the hood, do I know how they work? No,
To
but
the user, explain.
right to the user, right. So basically, if you've used queues before, you know you do an initialized queue, and as an input in the initialized queue, you can say a name. Just pick a name. In this case, the name is the name of the message. Happenstance.
Oh, so it's a global
By
resource.
design.
Named queues are global resources.
Correct. That's true. They're global to the application, but they're not blocking because of the fact that when we get the subscription message, we're just doing a preview here. Rather than doing a read, it's a single element queue. So if you want to change your subscription, what you do is you read it out, and then you change it and you push it back in. So I could have used a DVR maybe, but DVR wouldn't be
So
named.
you check it in, check it out every time.
Only when you subscribe, which happens very infrequently. Like the subscriptions typically happen at the beginning or at sort of key moments, but typically the subscriptions aren't changing very much in the application at all. It's mostly just sending and receiving. Yeah.
Can you create and destroy subscriptions at runtime, or is it only at edit time?
No, it's one place. Yeah.
Generate a brand new one,
Yep.
and so the sender, what is the lifetime of the subscription? What determines, does the sender have to exist for the subscription to exist?
No, it doesn't. And also, whenever any given receiver goes down, then it just basically removes all of its own subscriptions. And so then the senders don't send. Also, if the sender tries to send a message and the receiver's not there, then it also can remove the subscription. So if the receiver went down for some reason, then it just kind of gets removed from the communication pattern. I thought I saw a question there.
What happens if two modules subscribe at the same time to the same message? Do you lose subscriptions?
Well, you don't, because that is a blocking condition. So there's this queue here is a single element queue. So in order to be able to subscribe, when you read from the queue, you just set the timeout to -1. You wait forever until it shows up. And so you get it out, and then you add yourself to the subscription list. And then you add it back in, and as soon as that added back in, whoever's waiting for it can then access it. So it's like an automatic locking mechanism, effectively, when you have a one element queue.
So you don't use preview there, you use the actual read.
Sorry, I'm not giving you any time.
Is there any possibilities of like there being two Katy Perrys in the world and one Katy Perry doesn't know about the other, and you have two messages that are not
Right.
really the same?
Yeah, so it's absolutely possible that you can have any number of senders. That just puts the complication on the receiver or potentially on the data package inside of the data to be able to say, why should you care about me? And what's different about me than the other Katy Perry that's in the world talking at me? And also we have the other way around, which is if there are multiple Katy Perrys and you know which one's the real Katy Perry, you can talk only to the real Katy Perry and let the other Katy Perrys just ignore them. So that we call that addressed messaging. Do you want to talk? So this is Carlton Hurd. Oh yeah, I was going to talk about, let's see. So generally speaking, things are simple. I didn't show you so we have wizards, whoops, sorry. We have wizards to go to create messages, to create modules, that kind of thing. I didn't show those. They exist.
So I'm going to give the perspective as the customer. So I didn't have the desire or time or need to create something like this from scratch. So I was basically like a beta tester for Rob, and so I'm going to give the perspective of my application and how it's benefited me and how we use it. So Johnson Controls, we're basically a building solutions provider. I work in the heating and air conditioning division specifically in the residential units and the R&D testing of these. So the application is psychometric testing, and the first thing about psychometric testing is just knowing how to spell psychometric. But from Wikipedia, it's, if you leave out an R, you go into like some kind of psychotic testing, I guess mental things. But this has to do with basically whenever you expand gases and liquids, well, you can create air conditioning that way. So high level, we're just testing air conditioners. So here's a picture of one of our test chambers. We'll have two rooms. On the left-hand side is what would go inside your house. On the right-hand side is what would go outside your house. So they're aptly named the indoor room and the outdoor room. And what we can do in these cells is they're about 2 stories tall, but we can control the temperature and humidity down to within 1/10 of a degree and hold it there. So we can make especially outdoor room, we can simulate very dry 125 degree heat. It can be really humid. We can drop it down to -20 degrees. Here's an example of one cell where we can make it snow. In this specific test, we just dump snow on it for 12 hours and then see if it turns on. That's the whole test. Is, well, if you dump snow on it, or freezing rain in this cell, we can make it rain. We can make it rain and then freeze the rain after it falls. So you can imagine if you're in a place where you've got freezing rain, the ice is building up everywhere, the fan's probably going to ice over. Well, we want to make sure that it'll actually start and break the ice. And on the left-hand side is just an example of we've got tons and tons of different components that we'll swap in and out of. Again, this is an R&D lab. So what I do is I write the software to control these test chambers. It's all in LabVIEW, so here's just an example of one of the screens that we have to control. This is just the compressors for one of the rooms. So this is the, I guess, high-level LabVIEW architecture using the first PowerPoint smart art that I found. And again, but it's set up so that everything is modular, so that we can remove things, add things, and we're not going to care. We've got a lot of different hardware. Then our host interface will handle all of our screens. So our host interface is basically just one screen with a sub panel that will insert all of these other screens into. But our communication really is something that's more like this, where we just have all these messages flying around everywhere, and we use Jasma to do that. And if you're anything like me, 90% of your project is probably feature creep. So, we started off with a fraction of these, and I think I've got probably half of the modules that we're actually using, and then we've got others that we have to add down the road. So some of the challenges that we use is these different test chambers were built over the course of 20 years. So some were built 2 years ago, some were built 20 years ago. So you can imagine we use anything from VXI to then GPIB, then PXI, CRIO, CDAC, and we want to be able to swap out all the hardware without ever changing the rest of the module, or the rest of the code. So we will have a module that communicates with PXI, module that communicates with serial, communicates with all these different hardware, but they all use the same message. So it doesn't matter what hardware you're communicating with, it's all going to the same module, which is our calculation engine. And also the extensibility, this comes to the feature creep part of it, where we started off with a set of requirements, and then that got tripled, and every day that's probably 50% of my job is just keeping up with these new features. And so we can easily add, so like on the left-hand side is just an example where the engineers wanted to be able to see what's happening at the test cell without going to the test cell. So they wanted a remote viewer application. So we had to create a module that would handle that. And so we don't change any of the rest of it. We just add that module and then subscribe to the data coming from our calculation engine. And we can remove that, add it, do whatever we want. And the only thing that ties them together is that messaging. And yeah, the Excel stuff, databases. And then this last feature, which we use quite a bit, is interesting in Jasma, where normally you will have a message and it's like a broadcast, right? It's going to broadcast to everybody that's subscribing to that message. So in this case, we have a module that will read in the unit under test information and then send that information out. Usually that only happens basically once. So the operator will load that file in, and then it will send that information out to all the different modules that use it. We do have one, though, that's overview screen is basically like a big board screen. So we have these 65-inch TVs over the test cell, and it's just a nice looking thing. So when tours come through, they can go ooh and ah and see what's happening inside the test cell. Well, the problem is the cables seem to go in and out, so we lose connection to those TVs every once in a while. Well, whenever we reload that module or the overview screen, I want to be able to send that UT information back to this screen, but I don't want to send it back to all the other modules. So what we can do is, using that exact same message, we can reuse it, but there's an optional input where we can say, well, I only want to send it to this one specific subscriber. And so that's kind of just a nice feature that it's called address messaging. And so it's just a way where we can break that normal paradigm of the broadcasting, where we can say, no, I want to only send it to a specific subscriber. The only downside to that is, again, you have to know who is subscribing to be able to address it. And thanks to Rob, I'm kind of out of time, so I'm going to kill the rest of it.
You mentioned remote messaging. How do you send the messages to a remote?
So that one doesn't use the Jasmine to send those to the remote application. It's just another module that we use to package all that information and then send it over TCP/IP.
But we have done that before. So you basically just create a module that does the remote communication with whatever protocol you want to use, and you subscribe. Now, all the subscription that we've talked about has been very static, but you can do dependency injection on your messages if you want. You have to realize that every module that's responsible for receiving a message has to know how to handle it. So it's kind of simpler to just put it on the block diagram in the module itself. But if you want to, you can do it. We do have some instances where we do some amount of dependency injection. So for example, we have an interface with test that allows us to get JASM messages into a place where they can be read by test stand messages. And so how we do that is we have an engine that all it does is just subscribes to a list of messages that's passed to it externally. It's like, hey, this is all the messages that my test stand steps care about. And so then it just deals with them in a very sort of generic way rather than the specific way that I showed you. That makes sense.
Again, also coming at it from the user perspective, watching the first part of this presentation, there's a lot of that from the user I don't care about. For instance, even creating new messages, there's a wizard that you just have to say, I want to create this message, name it this, and this is what I want in the message. And it will automatically create the class and add it. And then all I have to do is, like Rob was showing, is I just have to add that class to either the transmission cluster or the receiving cluster for the module that I care about.
How easy would it be to plug in to that architecture, say, MC, say, standard names, which have both local?
Be pretty straightforward. You just create a module that would do it by itself, and then you figure out which messages that you want to, how you want to tie it to the application. Yeah, he was asking about, the example I think he gave was AMC, which is for TCP communication, if I remember right.
Right, but it also kind of has local messaging and remote messaging, kind of the same way. It assumes that you actually, your message consists of text message header and text message data. So you
right.
have, instead of variant, for example, you would need to do flip and that. Mm-hmm. But it's pretty nicely, kind of generalized both.
Well, yeah, I mean, we only are dealing with communication inside of an application. We assume that we only want one mode of communication. So we're not mixing lots of different types. And that's all within the application. If you want to create an external interface, whether it be using AMC or whatever, you can. I don't think I would want to use the local messaging at all because then I would end up having two different types of local messaging in my application. So I would just, if you really wanted to use the remote part, yeah, or if you wanted to do that, I guess you could, but I wouldn't recommend it.
I mean, you need a proxy like the network endpoints and active framework. You need something that's going to handle the connection and then shuttle messages back and forth.
Right. Yeah. Yeah, and we've done that with TCP before. It's the key point is that then that proxy right there can be largely independent. In fact, the TCP solution we had, we actually tell it dynamically. We just pass in an array of messages. Like, here's all the messages that are going to be going across the network. So we talk one JASM application, say on a host, to another JASM application, say on a real-time controller. And then we have that proxy in between that's making the TCP connection. And we just give it the list, hey, here's all the messages that need to go across the boundary from one direction and then from the other side, and you're done.
You need to make sure they've uploaded both targets.
Yes, that's true. They have to be, I mean, strict type def cluster are pretty straightforward.
That's what I do. That's what's nice about having this is that, again, the module aspect of it, right? We have a module that handles TCP communication, another module that handles data socket, another module that handles variables, and it's just, so if you want to use whatever communication architecture you want or communication method, that's fine. You just build an architecture. I just use Jasma as a way to communicate between modules in my application.
So I was thinking that it makes sense to create pretty abstract communication, library, class, whatever, interface, whatever you call it, which would be, basically send message, receive message.
Yeah, and that's what we have.
And then what transport underneath you use, whether you use ANC, whether you use just queues, whatever you want to use, it's up to the particular implementation of that.
Right, so we do have that as an option if somebody wanted to dig into it, because we did make the routing of the messages. That's a class that could be extended. We only use queues, but we recognized early on, actually because of Mark Bala, when I first presented this concept in 2011, then he helped iterate it a lot and sort of pointed out that, hey, you have this option where if you want, you could use a file to transfer messages even. Did you try? I think you might have tried that even, just for the sake of doing it. So it's possible to do. We haven't done it. I don't honestly see the need to do it. But if you want to.
Do you use anything like flat state machine as the main reactor?
Personally, I don't, because I find that that's the easiest thing for my developers to understand.
Okay.
I was there when he created this, so.
No, but I mean, did you ever run into state explosion problem?
We haven't run into that too much because each state, okay, well, I guess it depends on when you think it's a problem. Right?
It seems to be a problem already, and that's very limited functionality.
Right. So the state, let me put it this way. I haven't really had a problem myself, and I haven't seen a problem with far less experienced developers. So if it's a problem that I need to overcome, I'll deal with it then. Is my approach. Yeah, Mark.
So one of the questions is, how do you manage spawning up the modules in the order that you want them to? Mm-hmm. So if your sender spawns up and he sends a message, but the receivers haven't spawned themselves up?
Sure. So that's a good question.
So your actors can start on actors, right?
Well, so yes, you can. But like I said, I mean, you can choose to do it statically. If you choose to do it statically, there's actually a built-in feature that you can just tell it a list of module names, and they'll all wait for each other to be done launching. So it's just a simple solution that you can just say, wait for those. Yeah, that's pretty useful.
So what is this VI? This is the module itself?
Right, so this is one module right here. If you're coming from the actor framework, then a lot of the actors launch their modules effectively. So
yeah, you pass in the actor object and it
right,
spins up everything.
Right, right. Which that's not the way this works. The way that it's written. If you want to write it that way, yeah, you absolutely could. But honestly, that launcher layer hasn't proven to provide value in most situations for our company. So it's just another layer to get through in order to get to what I really want to do, which is figure out where the problem is or put in my new function or whatever. We have done instances where we've done dynamic launching of n number of modules for whatever reason. So like execution engines and things like that. Most of the time we just do it statically because it's easy.
So
Yeah.
if you send, since you're like double abstract on those messages, if you send a message, the receiver's not there, the default action is it's just going to get dropped off the receiver list, right? Do you have the error handling built in so that the global application is now aware that a message isn't getting through and that particular receiver seems to have disappeared?
Yeah. Yeah, and so you saw that little pop-up that came up when I ran the application. There's like 7 or 8 different exceptions that it reports. That's one of them, and it tells you, here's the message I tried to, or here's when I sent it, here's the message I tried to send, here's who I tried to send it to. They weren't there, so I unsubscribed them. And that gets this, for the user, there's a pop-up. You can choose whether it's modal or non-modal. And then you click on it to get more detailed information. You can get the history of every exception if you are really having trouble. And also you can alternatively log it to files. So you can see on the bottom there the log folder path control is wired in there. So it just creates a text file that you can import into Excel. It turns it so you can format it nicely. But that way you can tell whatever problems you had, here's a list of them, here's when they happen, and it'll help you out to debug. But also gives you that immediate feedback too while you're running, so you can investigate a little bit or try to replicate or whatever. Yeah. One of the things somebody brought up, but is a concern or consideration when you're using queues versus event structures. I mentioned event structures have the infinite bound problem. So I've chosen in this architecture to use limited queues. So you can choose how big they are, but let's just say you want 50 messages on a queue.
Do you watch the number of messages not out from the queue?
Yeah, you do. In fact, so you can do that. The output of the receive message, it tells you how many are in the backlog. And then if you try to put a message onto a queue that has, I think the number is 80% or something like that, that of the queue is full.
The sender will know that it is fulfilled. You check in the sender too, or only in the receiver?
Well, when you send a message, it checks to see how much backup there is, and if there's, is that true? I don't remember if this is on the sender or receiver side. Yeah, it's on the sender side.
What will the sender do if the queue is full?
If the queue is backed up, it starts sending out exception messages. When it backed up is considered 80% of the full. Yeah, to the exception handler. I mean, it sends them out generally, but there's an exception handler module that's there to catch them. Yeah, so it gets them and logs them and reports them. If the queue is full, then it just unsubscribes. Lets you know about that too. So that's the downside. We had to choose. It drops the subscriber, yeah, because it's assuming that subscriber is having trouble. So we had to choose. Do we bring that subscriber down? Do we bring the entire application down? If we were just using queues, it's sort of your typical use case. You generate an error cluster, and then things would go down. So we chose to do it this way, where we're reporting it. We could choose to do it a different way if we want.
But like for instance, in my application, there's one module that just depending on what happens, we could have seen that backlog built up. But most of the time, I just don't care if it builds up to the point where I know it's going to eventually get caught back up. But if it ever gets that warning where it's 80% of the backlog is full, then it will just dump everything it's doing and saying, okay, I don't care, catch yourself back up. So you can do on the receiving side, you can also determine what you want to do so that you don't ever actually exceed the queue size.
And then the other thing you can do too is there's 3 different types of subscriptions. The normal one is what I described. There's also a critical subscription. What I learned is when I went into this idea initially, I thought, well, there's critical messages. So if you're making a messaging architecture, get rid of that idea. There are no critical messages. There are critical subscriptions for messages. Some modules will really care about your data packet. Your user interface modules won't care as much about your data packet because it's just displaying it. So if it backs up, you don't really care about all that old data for a user interface. You would only care about the most recent data, right? But if you're doing a data logging module, then you will care about every single data packet. So your subscription is what's important. So every time we subscribe, we can specify whether we want a normal subscription, which is what we've been talking about up until now, or a critical subscription, which means put it at the front of the line, or if you want a background subscription, which means in the case where the queue is 80% full, then just drop the message.
So
Don't
it's
care.
just 3 levels of priority.
Yep. Yeah.
Do you support the concept of a status description where there's only one element ever allowed in the queue, and you always force new element over the top of it? For instance, you have a temperature sensor that's saying this is the current temperature. Nobody here cares what the temperature was 5 minutes ago. They care about the most recent data only. Do you support something like that where each time you read, you just read the latest value?
No essentially
Well,
before.
Yeah, essentially.
Yeah, I wouldn't do that because the queue is on the receiver end. So in that case, the sender is assuming information about the receiver, and I'm trying to decouple the sender receiver completely, right? So,
well, I'm saying it's a message that history is irrelevant. This message is simply, the name of the message is the current temperature.
right.
So it's always the current temperature. You don't care about the history. No one's ever going to care about the history. Can you implement that using this system?
No,
you don't have
because
a
the receiver queue has to handle other
Yeah.
messages as well, right?
Right.
So the receiver queue is where the parent message class goes in. So your current temperature message, yeah, it's never going to have history because when it gets put on the receiver's queue, the receiver's queue maybe is handling all of the other messages like the pressure and the whatever else you're measuring or whatever else it's receiving.
Yeah, that's true. And when it dequeues a message, it's not going to go and look at all the ones that are coming up and saying,
Yeah.
oh wait, do I have other copies of that? In that case, I can.
So you would be dedicated to if you wanted to be.
Yeah, that's not just
Yeah.
something you should use a message for. It's
Right.
different.
Yep, that's true. Yeah.
You mentioned you had some tools for the developer to help get the building. Do you have tools to help debug the messaging as well?
Good question. So the exception handler is the one that I have. I have aspirations though. So in Jasmine, it actually keeps track of the statistics of every module on a second basis, so that I can get out throughput information. Like there's latency information, obviously. So it'll tell you for every second what was the maximum message latency, what was the maximum backlog number. It'll tell you how many messages were received, that kind of stuff.
The template of every module?
It's just built in.
Built in into the,
Yeah.
basically into the template of what we should already.
Yeah, it's built into the common VIs that are all shared.
Yeah.
And you can read that information with like a property node read or or reading properties. But I actually intend to write a module that just basically collects those and then displays them. So if you want a diagnostic screen, you can bring it up and it can say every module, here's all its throughput and everything. And one of the things that's an advantage over with the question I was prepared for, no one asked, was how is this different from just using an event structure? Anyone want to ask me that question?
How is it different, Rob?
Oh, okay. So it's really in the subscription. So what does a subscription mean? For the event structure is basically it's going to magically receive these things, right? So what I did is I put more stuff in the subscription information. And so when you subscribe, it's also logging it to like a central repository of here's all the messages, here's all who's subscribed to what, and that kind of thing. So that way I can use utilities if I need to. This is not code that you should use regularly.
Did you say that that information is separate for each
It is, but so if you have the list of messages, then you can get any of the subscription lists. And it's easier to have just one list of modules. So that's just like globally stored information that I can access at any point. So the idea would be to have that if you needed a diagnostic screen, that you could pop up and say, Here's all the modules that are running now. Here's all the messages that are active now. Here's all the messages and all the modules that subscribe to each of those messages. Here's all the messages and all the modules that send and all the modules that receive. All that information you can get from the module. So that's my kind of next step, is to write that kind of support if it's helpful. Honestly, we haven't had many problems with stuff like that. The exception handler handles pretty much everything that I would want to do. But I've always thought that would be really cool. I just haven't really been able to justify it, like, oh, I have this critical problem, I better write this thing. Other questions? I know we're at 3:36. I don't know if I'm going to listen last week.
What data communication method did you choose for your application to communicate with this?
So it's just TCP. I had an old TCP module. Actually, I'm thinking about switching to, what is it, the MQTT, is that right? That's what it's called. I don't know. I learned this week about a different protocol that I think would be interesting to try, and it'd be pretty easy to just, swap it in, since it's just a module. So I write it the same way, just the only difference would be the protocol. Yep.
So when you write a new module, a new sender module that's sending you, how do you go about unit testing?
That is a great question. So one of the things that DQMH does really well is focus on that kind of testing. That's not something that we build in. The way you would do that is basically manually write what DQMH does, which is a tester that you would send the messages that you will receive and receive the messages that you will send back. And it's doable because of the fact that that all those messages, it's just another module. You could even run it in parallel with your application if you really wanted to, although that would get confusing, I would think. But let's say you had you wanted to inject messages into an existing system, and you wanted to inject into all of the receives of that message. That'd be super easy. We do that sometimes when we're debugging. Yeah.
I don't know if I get that correct, but can I unsubscribe to some message during runtime?
Yep. Yeah, you can subscribe to any message to send. You can subscribe using any of the 3 levels.
Yeah,
you can unsubscribe. Yeah, you can unsubscribe, because that's what it does when any given module shuts down. Now, when you look at the static application, it's kind of assumed that they're both going to end at the same time. There's a lot of built-in messages. One of them is the shutdown message.
Is the send a method of the message itself?
No. Send is a message of JModule. Is a method of JModule. So it's
you pass it a message object.
I pass it a message object. It handles the sending. So that way, the JMessage, it doesn't have to know anything about subscriptions. JMessage it's really an empty shell, especially when you compare it to like the active framework. It literally all you do is you create it or you read its data. Done. If you want to, and we have occasionally done this, you could add more methods to a message if you know who its receiver is, because of some, like good example would be a database query. So if you know your database module is getting it, then maybe you might want a method there, but realistically, that's probably mixing things you don't want to mix. Yeah.
So,
yeah.
Maybe a question that was answered early on, but the modules themselves are classes or not? I'm just wondering about the object-oriented nature.
No, good question.
If you inherit from a module, are they classes?
So when you look at the structure here, so there is a class that is called JMessage, and those JMessages inherit from it. There is a class called JModule, and those modules inherit from it. That's how it does all the sending and receiving, is because the sending and receiving messages are at the parent level. They're the parent level methods.
But you're asking about these, right? Like
Right.
the actual, I guess,
Yeah, so when you inherit,
module.
if there's only one, I'm familiar with actor framework, so the actor class has the message handler, so it's the same, the J module class has the actual message handler, so you inherit, and it's just defining more messages that you can receive in the chat and the shoulder.
Right, and then sometimes you can do multiple inheritance levels too, right? So we've written some stuff internally where it's like, Maybe we want a module that acts as a subpanel, right? And we want multiple different modules that act as a subpanel. So one way of doing that, since we can't do multiple inheritance, is to say, all right, well, what we're going to do is we're going to have J modules here, and underneath of it is J module subpanel. And underneath of that is whatever UIs that I want to be subpanels. And so then the handling of, sticking the reference in the subpanel control and pulling it back out again. And by the way, you got, now I'm paying attention to you, now I'm not paying attention to you. That kind of stuff can all just be built in at that level. And the problem is, this is where I'm interested in interfaces if that comes, is to sort of play around with can I sort of do away with some of the hierarchy that I have and just use interfaces instead. I'd like to
be clear though, the modules don't have to be classes in order to use Jasmine. So I don't use that. The only classes I'm using are for individual tests.
That's true. This is a template, so you could do containment instead, where you put the J module inside of a regular status cluster, and then you have to pull it out every time to use the J module methods and put it back in. And that's kind of annoying, which is why I started thinking about doing it as a class. But one thing I hope you realize, especially if you're not that comfortable with object-oriented, is ultimately when you get into a method that's inside of a class, it's basically a cluster, right? So you do your unbundle and bundle by name. I don't even know if there is any data. Yeah, not so much. Not so much data. So the data is just stored in this status cluster right here. So this is a cluster that's inside, that basically defines the properties. I did this purely for ease of access on the block diagram, so that I didn't have to go into the class in order to get it. I just put it here. So anytime you want to add data to your class, you just add it to the cluster instead. The cluster is inside the class. That's just getting around lab view limitation than anything.
Seems like a UI improvement.
Yeah, if I could just right-click in this wire and say open class data, that would be cool. I'd take that. Then I wouldn't have to do that nonsense.
Oh, Darren left.
No. Sorry. Yeah. So I have done some cool stuff with right-click framework as related to Jasmine, but I am actually showing this in 2014. So, like for example, one thing that was really cool. Like, unfortunately, right-click framework I've found to be very crashy, so I kind of don't like it that much. But what you can do is on the send, if you right-click on the input, on the JMessage input, then it'll actually figure out which messages you're subscribed to in that module, and then give you the list of all the create methods for just those JMessages. And so that way you can pop that on there easily, which is really cool when it works. But like I said, right-click framework, yeah, not as great as I was hoping. I'm talking the NI version.
Back to your LV project. So basically, you have only two base classes, one for messages, one for.
I have a couple other ones, but like the subscription one, and there's one called router, and the router is just to provide for support in the future for if somebody really wants to use a different method other than queues. But I don't really see that changing. So I've got a couple for the subscriptions because each subscription type handles things a little bit differently, but there's almost no methods in them. So the primary ones really are JMessage and JModule. The rest of them are sort of reciprocals. Relatively speaking. All right, well, thanks a lot for hanging in there with me. Yeah, come on up and talk if you're interested in more conversation.